As we discuss hydraulics, we often refer to Q as being the design flow rate, and it is typically given before we can start any calculations. So before we talk about calculations in hydraulics, I think it is important to tell you where the design flow rate, or Q, comes from. Q can be a function of the number of people you want your water or sewer system to service. Q can also be a function of the number of housing units or dwelling units within the service area of your system. And finally, Q can simply be a function of the service area in your system. In other words, each of these unit demands, individually or in combination with each other, can determine the design flow rate for a given water system. As you can imagine, the unit demand, whether it be per person, per dwelling, or per unit area, varies by region. Therefore, each water agency will determine the typical unit demands within their service area. And they do this by simply taking the total volume of water sold in a given year and dividing it by the total number of people, homes, or area within their system. The result of this simple analysis is what we call the average day demand. However, we do not design systems based upon the average day demand because this would mean roughly 50% of the time our system is not functioning as needed. If we look at how the water demand changes throughout the year, we can expect to see higher water demand occurring during the summertime. During this peak season, there is a 24-hour period that represents the maximum daily water volume that will need to be delivered throughout the system. This 24-hour period is simply referred to as the maximum day demand. However, we still do not design our system strictly based upon the maximum day demand because our water usage varies throughout the day. For a typical residential house, we should see a higher demand in the morning and evening as people are washing, eating, and performing other household chores when they are at home. During the middle of the day, we expect to see less demand as less people are at home. And the mix of this variation is a 60-minute period referred to as the peak hour. In a given water system, the maximum day and peak hour demand are often a function of the average day demand. For instance, the maximum day demand can be 150% of average day, while the peak hour can be as much as 400% of the average day. The maximum day is also used in conjunction with the fire demand, or fire flow, or the minimum fire demand specified by the local fire agency. Some agencies specify analysis criteria for all three demand scenarios. In other words, you need to analyze your system once for each of the three scenarios presented. At a minimum, every agency provides analysis criteria for the max day plus fire flow scenario because this typically dictates the design of their system. For sanitary sewer demand, we determine the average day demand from the unit demands provided by the local agency, but then we also apply a peaking factor, which is a function of the diurnal variation, meaning the daily variation, just as with the water demand. But the peaking factor is also a function of the weather conditions. Because sanitary systems are gravity flow, then there is a certain amount of wet weather infiltration that can be accounted for through the peaking factor.